and documentation. And what we will study in this basic topic, basically we will study what do you mean by code review, what are the types of code review, what do you mean by software documentation, what are the types of software documentation. Okay, and I am your instructor, Ms. Shruti Rawal. So let us quickly jump on to today's topics. So the outline of today's lecture is, the first thing that we will see is software quality, and we are not going to see what do you mean by software quality, but actually what problem occurs while maintaining the software quality. That is the thing that we are going to study today. The next thing that we are going to study is code review, and in code review, as I have told you, we will discuss what are the different types of code review, and we will see in detail both of the types. And the last thing that we will study today is software documentation. In that we will see the types of documentation. So let us jump on to our first topic, that is software quality. Now we all know what do you mean by software quality, and there are different parameters on which we can measure the software quality. Let us take some example. For example, you can say reliability is one of the software quality, right? And what do you mean by reliability, or what do you mean by saying that my software is reliable? You can rely on the software when all the things that you want from the software, it produces on the correct time. Like for example, if you are searching for something and if Google gives you the correct result, then you can say that Google as a software is reliable, right? Now when you are searching or when you are viewing the result in your GTU website, and if your website crashes, can you say that your GTU website is reliable? No, because when we wanted to view something, that software actually does not produce that thing, and we can say that reliability quality is not up to the mark for our GTU website, right? There are certain other parameters also for software quality, like performance, throughput, you can say CPU usage, caching, right? So these all are different parameters on which we can say that software is a quality software or a bad quality software, right? But we are not going to discuss what is software quality in this lecture. We are instead of this going to discuss that software quality in any organization is always at stake. It means that we are always in a condition that whether our software will maintain a quality or whether it will not maintain a quality, whether we will be able to produce a good quality software or bad quality software. There are number of reasons due to which our software quality is compromised. But can we hold any one person or any one team responsible for not maintaining the software quality? Now in a software industry, always there is you can say a battle between a customer and developer. Why? Because always the customer says that whatever you are delivering, that is your software organization is delivering to me, that is not a quality software. You always have some sort of bugs in it, and due to this I am frustrated, right? So customer is always blaming the developer, whereas the developer is always blaming your customer. Developer is always telling that due to the inconsistency in requirement analysis, that is the lack of detailed information while discussing the requirements with the customer, my software is not quality software, and it is not due to me, it is due to the customer. So there is a blame game going on between customer and developers. Now who is right and who is wrong? What do you think? Yes, exactly, both are correct at their own places. Customer is correct in telling that developer is not maintaining the quality standards, and the developer is also correct in saying that customer is not giving enough information for producing a software. So both of them are correct. As a result of this, our software quality is always at stake. Now, what can be the measures we can perform for maintaining the software quality? One of the things that we can perform in a software organization to maintain a software quality is doing periodic code review. Now what do you mean by a code review, or what do you mean by a review? Review is a technique in which number of people, or you can say a group of people who are known as reviewer, right? They are the person who are part of the review team, will actually check your software and give you some feedback. If there are some inconsistencies or errors in your software, The review team will give you feedback, you will rectify those errors, and then only you will go to the next step or deliver it to the customer. So this is the whole review. What do you mean by code review? Now, why is this code review important? This code review is very cost effective strategy. Why? Let us take an example. For example, if you have a requirement document, right, and you have not done any sort of code review in this requirement document and you are shifting to the design phase. We know there are different phases of software engineering, starting from requirement, designing, coding and testing, right? If you are jumping from requirement phase to design phase without reviewing the actual requirement document, what will happen? All the errors that are present in your requirement document will actually propagate to the design phase, and due to this, the design that you will create, the architecture or the component design that you are creating will consist of errors, right? So this will ultimately increase your software cost that we don't want. As a result of this, code review is a very important process that should be held after all the syntax errors have been completed or eliminated. Now, as I told you earlier that there are different types of code review. There are basic two types of code review. The first code review is code walkthrough, and we will study in detail what do you mean by code walkthrough, right? And the second type of code review is code inspection. Now you can say the basic difference between code walkthrough and code inspection is that code walkthrough is an informal code review, whereas code inspection is a basic formal code review, right? Now let us study both of them in detail. So the first code review technique that we are going to see is code inspection. Now what do you mean by code inspection? As I have already told you, code inspection is a very basic and formal technique to review your code. Okay, and what does code inspection actually do? It checks for presence of common errors in your software. What do you mean by that? It means that every developer makes some common mistakes. Whether it is you, whether it is me, we all make mistakes because we are humans, right? But there are some mistakes which are general, and your software organization makes a checklist of all those errors which are commonly present in all the programmers' coding, right? So inspecting such errors in your software code is known as a code inspection. So basically, code inspection is looking on the errors which programmer makes, and it is oversighted by the programmers. It means programmers are not aware that we have made these mistakes, right? So this is the basic procedure of code inspection. Now who will perform code inspection? Because I am a programmer, if I inspect my code, it is possible that I am not able to inspect it or review it properly. As a result of this, there will be some fellow colleagues who will be given my code, and they will be given a checklist, and in this checklist there will be some common errors which are occurred by every programmer. So these fellow colleagues will take this checklist, they will take your code, and they will search if this error is occurring in your code or not, right? So this is the procedure of code inspection. They don't have to think very much in code inspection because they already have list of errors. They just have to go through your code and check whether that error is present in your code or not, right? Now let us see what are the common errors that occur in day-to-day life by all the programmers. So you can see the first error is array index out of bound. Now what do you mean by this error? We know that array is a fixed size data structure, right? But many a times we try to insert values more than the size that we have specified in the array, and then in such a condition this error may occur. Now this is a very trivial, or you can say very basic mistake that is done by most of the programmer, right? The second mistake, or you can say second error, which is very common in all the programmer, is use of uninitialized variables. Now what do you mean by using uninitialized variables? If you have declared a variable and you have not assigned any value to that variable, but you are trying to print that variable, right? So what are you doing? You are basically using a variable in which you have initialized nothing. So that sort of inconsistency in code is very common in all the programmers in software industry. So that is also one of the common error. The next is jump into the loops. Now while we were studying coding standards, we have already discussed that jumping into the loops, right? For example, using of go to or using of break statement. Such statements actually are statements which are not recommended by software industry or any organization. And if your programmer is using such statements very heavily, then his or her code is not a quality code. In code inspection, the fellow colleagues are told that you have to review the code in such a way that you have to check whether they are using these jumping statements heavily or lightly. If they have used them lightly, it is okay, but if they are using many go to statements and many break statements, then the whole flow of your program and the control of your program is not readily understood. So that is a problem, right? The next thing or the next common error is non-terminating loop. Now we know that loops are very tricky to work with, and many times it happens that we have designed a loop which is never completed, right? So we don't have a terminating condition and it is never ending, it goes into infinite loop. So if you have such a non-terminating loop, it is possible that your software may crash, and this is one of the error which can be overlooked by a programmer, because we know that we use loop very heavily, we use loop many times, but many times it is possible that any condition or a particular condition is a non-terminating, right? The next you can say common error in our code is incompatible assignment. Now what do you mean by incompatible assignment? It is related to incompatible data type, right? For example, if I have some variable that I have declared integer type and I am assigning the value that is float type, right? So what is this? This sort of assignment is known as incompatible assignment because the data types are not matched, right? And the next is incorrect precedence of logical operator. Now you know what you mean by operator precedence, that you have studied in data structure, you have studied that in your prefix to postfix conversion, right? So we are well aware about operator precedence, that who is given more precedence, right? So we know that all the operators like plus, minus, division, multiplication, brackets, carry, everything has its own precedence number. Now many times if you are formulating a formula, you might have missed this sort of operator precedence and it might overlook by most of the programmers. So these are the common errors which we need to inspect in a programmer's code. So code inspection again is a technique in which this commonly occurred error by the programmers are actually checked, right? Now let us go to the next technique of code review, and that is code walkthrough. I've already told you that basically code walkthrough is an informal meeting, okay? And when does this code walkthrough actually occur? When your code is completed. For example, let's take an example that if you are working on a particular module, you have completed that module. What you will do? You will say that I am ready for this code walkthrough, and your code, that is your module, will be given to some of the experts in your company. They will analyze your code before the actual code walkthrough meeting occurs. They will analyze and they will actually write down on their own that what are the suggestions from their side. Now these suggestions are not actually coding related. They may be basically related to the logic that you have implemented. They may be related to the algorithm that you are using, right? For example, it is possible that you have thousands of lines of code. Now, optimization of LOC is one of the basic quality features that every programmer should accommodate. But many times it is overlooked by the programmers. They write thousands of lines of code and they don't try to optimize it because they are basically trying to deliver the software in time. So quality is compromised. In code walkthrough, all the team members who are actually going through your code or reviewing your code will see that whether you have optimized the code for LOC or not. There is a possibility that there is some sort of logic mistake or algorithmic mistake in your code. That also is seen in the code walkthrough. Also, the next thing that is seen in the code walkthrough is time complexity and space complexity, right? There may be a balance between time complexity and space complexity that you have given, but it is possible that you can optimize your complexity as well by using some another algorithm or some other method. The programmers who are given to review your code are experts who have already coded such things in previous projects. So they will list out what could be optimized in your code, and after this whole reviewing of their own is properly so actually what you are doing, you are giving your code to some of the reviewers. The reviewers are reviewing it at their place. They are noting down the inconsistency and the suggestions from their side, and after that an actual review meeting is taken place. Now there are some rules and regulations for this code walkthrough meeting. Let us discuss them. The first important rule of a code walkthrough review meeting is the number of participants in the meeting should be limited. Minimum number should be 3 and maximum number should be 6, including the person who has actually written the code. Right. So there will be the author of the code, there will be a programmer who is leading this meeting, and that programmer who is leading this meeting is not equal to the author or the person who has actually written the code. He will be some expert in this domain or this particular technology. Now the reviewer members have already gone through your code at their home. They have noted down some of the inconsistency or suggestions from their side. What will happen in the meeting, one by one, everybody will be asked, what are your suggestions for this particular code? Everything will be discussed in the meeting, and in this meeting we are not here for debating, right? We are not here for actually judging the person who is the author. We don't want personal clashes to be discussed in this meeting. We are here professionally and we need to review the code and not the actual author, right? So that is the main aim of this meeting, that we are actually reviewing the code based on algorithm, logic and optimization, and whatever the suggestions of the reviewer are there, that all suggestions are noted down and given to the author. Author will then try to implement or include all the suggestions that are given by the reviewer, right? So this is known as code walkthrough, and this was the last technique of code review. Now let us shift on to our next topic, and that is software documentation. Now when documentation word is heard, what comes to your mind? It means that there is a pile of paper that comes into your mind, right? Yes, documentation is that thing. But in software industry, the documentation is basically divided into two broad categories. What are they? The first category of documentation is internal documentation. Now what do you mean by internal documentation, and what all things can be included in internal documentation, that we will see in the next slide. But let us see what is the next type of documentation. The next type of documentation is external documentation. The basic difference between internal documentation and external documentation is that internal documentation is the documentation in the code itself, right? So all the coding standards that we are using in the code, that can occur in the category of internal documentation, while all the other things that we are actually preparing, that is the supporting documents, come under the category of external documentation. Let us see in detail each of them. The first documentation is internal documentation. So if you are a good software organization and if you want to maintain a reputation in market, then we have already discussed that there is a particular coding standards and guidelines that your organization must follow. Now these coding standards and guidelines may be local to your company, or they may be the general standards that are followed by everyone, like IEEE standards and ISO standards, right? But any of the standards that you are using, that the programmer must use, right? Just formulating the standards and not using them is not internal documentation. Internal documentation are actually the documentation, or you can say it is a code perspective in which you are actually incorporating all the coding standards and guidelines of your company and the general standards. Now let us see what all things can be included in internal documentation. The first thing that can be included in internal documentation is commenting. So we have already discussed this, that commenting is a very good programming practice. Every programmer who codes in real life, along with code, they have to write comments, right? Why should they write comments? Because the readability and the understandability of the code increases if you have a proper commenting in your code. The next internal documentation is the module header comment. Now we have categorized this. The first category is the normal comment that you are writing inside your code. Module header comment that we have already discussed in our previous lecture is a header comment that you are writing before starting or before coding the module, right? So there is a particular author who will be starting the module, and before starting the code of the module, there will be a proper format of the module header, and that module header is nothing but it is a commenting in which you will specify what is the module number, what is the module name, what is the module description, what are the functions that you are going to use, what are the input and output parameters. There is a predefined format for that particular module that you have to specify before starting the actual module, right? So that is also very important, because if, for example, if you are the author of that module and for some XYZ reason you are leaving this company, you will be handing over this module to some other person, right? Now that colleague or that other person is unaware about what this program or what this module is all about. If you have done proper commenting inside the code as well as in the module header, the fellow person whom you have handed the code will easily understand what this module is all about, what are the functions, what are the input and output parameters. So he may interpret the code and easily understand it, right? So that is the basic internal documentation related to commenting. The next is variable names. This also we have already discussed, that we have to give meaningful variable names inside our code. If you give variable names like A, B, C, D, is this a good strategy or a good coding standard? No. For example, if I am storing something in a variable which is sum of some numbers, right? So I can give my variable's name as sum, because that variable should actually depict what is being stored inside it. So the variable name should be meaningful. That is also because if I am handing over this code to some other person, or even I am looking to this code after years, I should be able to interpret what this variable is actually doing, right? The next is code indentation. This also I have already discussed in the coding standard, that you have to give proper indentation to your code, right? If you don't give proper indentation, you might get confused while debugging the code or finding the errors in your code, right? The next is code structuring. Now what do you mean by code structuring? There are many times when programmers foresee the code structure, right? For example, if there is a piece of code which is used at many places, what do? They use it or they rewrite it many times. Now this is redundancy. We want to reduce this whole redundancy. And we know that if you make the function of that particular piece of code, you can call this function wherever it is needed, right? So that is a better code structure. Wherever it is possible, you can use inheritance, right? That is a basic object-oriented concept. You have to use such concepts that you have studied in your college, and you have to incorporate that all concepts in your coding. If you are not using these sort of code structuring, then your code will be difficult to interpret and maintain. So these all are the things that are included in internal documentation. Now let us shift towards the external documentation. External documentations are the actual, or you can say the literal documentation, which are the supporting documents of all the work that you are doing, starting from the requirement till the testing phase, right? Now, if you are a good organization and if you want that people say that you are maintaining the standards, then you have to deliver this, or you have to produce this external documentation in an orderly fashion. Now what do you mean by an orderly fashion? Orderly fashion, it means that if you are in the requirement phase, after your requirement phase is completed, you must have your software requirement specification. If at that time you don't have SRS, then it is of no use at the end of your project, right? So in orderly fashion, it means all the supporting documents must be completed in a timely and orderly manner. Now let us see what are the example of external documentation. So the first example of external documentation is user manual. Now what do you mean by user manual? You must have heard this word number of times, right? For example, if you are purchasing an air condition and if you are unaware how to use this air condition, you have a supporting document known as user manual in which there are steps to use those air conditions, right? So that sort of user manual you should produce for your software also. Why it is necessary? Because many times your software is used by person who are not technical person, who are novice and they don't know how to use your software, right? So by producing this user manual, the user, that is the actual end users who are going to use your software, will get an idea where to navigate or how to use this software, right? The next external documentation, or you can say supporting documentation, is software requirement specification, that is SRS, right? We know what to include in SRS. We have already studied the whole requirement analysis and specification unit. But when to produce SRS, that is to be produced while you are actually deciding on the requirement, right? So a good SRS document is very necessary for the successful and quality product, right? The next document is design document. After you have completed your requirement analysis and after you have your software requirement specification document with you, the next phase onto which you will jump is designing your software. Now this design will include your architecture design, it will include your component level design, it will also include your UI design. All these are different sort of designing, and you must have a proper designing document through which you are referring the document and then you are performing the design, right? So that is a design document. And the last document in external documentation is the test document. And what do you mean by testing document? Testing also consists of number of documents. For example, you will have a test plan document, right? So it means that in test plan document you will have all the things that you will do while testing, right? All the planning that you will do while testing. Also you have test case documents, you have test metric documents, different sort of testing documents. These all are the supporting external document which includes all the things that you will perform while testing and what you will actually deliver or what is the actual work product of testing, right? So this was all about external documentation. So this was all about today's lecture. Thank you.